All right, so here we are. We're going to start learning about the mole. I know you guys are all really excited about that. Nope, it's not the little animal. And if you watch the little video, you will know that the mole is something called Avogadro's number. It's a very large number because atoms are so incredibly small. We need an exceptionally large number of atoms in order to actually weigh them. So it is made up of 6.02 times 10 to the 23rd of whatever you're talking about. In chemistry, we could be talking about atoms, we could be talking about molecules, we could be talking about formula units. It doesn't really matter, okay? When somebody says how much is a mole, it's 6.02 times 10 to the 23rd. So here's the number, and it's extremely large, 602 sextillion, as you would have gotten from the video that you were supposed to have watched. A very large number. So when we think about the mole, let's just talk about something that's more common to us. So if somebody said, I have a dozen uranium atoms, what does a dozen mean? And you all should say 12. Yes, you are correct. Same thing with a pair. If you have a pair of uranium atoms, it's 2. Okay. So on the same regard, if you have a mole of uranium atoms, then that is just 6.02 times 10 to the 23rd. So it's just another way, it's like this nickname for this number. If I said, what if I had a dozen water molecules? Dozen means 12. What if I have a pair of water molecules? A pair means 2. What if I have a mole of water molecules? Again, it's just this incredibly large number, 6.02 times 10 to the 23rd. So what about people? What if I said how many people are in a mole? Same thing, 6.02 times 10 to the 23rd. This is such an incredibly large number that there hasn't even been a mole of people ever alive throughout all history. People that have been alive and died. We've never even had a mole of people. So again, review. I have a dozen pennies, means 12. I have a mole of pennies, it means 6.02 times 10 to the 23rd. So if we had a mole of pennies, that would be enough to wrap around the earth 270 trillion times, or it would cover the entire earth to a depth of 300 meters. This is an incredibly large number. When I was in high school, my chemistry teacher said that she was collecting a mole of pennies. I never really understood, but that's not even possible. You can't do that. If you had a mole of dollar bills and you were told to spend $1 trillion per second, it would take you over 19,000 years in order to spend a mole of dollars. So big. So here we are. We're in chemistry and we're talking about atoms. And because atoms are so incredibly small, we have to put them into bunches called moles, 6.02 times 10 to the 23rd. This does not weigh the same as a mole of pennies. I mean, an atom of carbon is much less than a penny. So a mole of atoms must weigh significantly less than a mole of pennies. So a mole of carbon, we can just look at the periodic table and see that on there it says 12 grams. So right there on the periodic table, it gives us the answer. Whereas a mole of pennies, again, this is so many pennies, 2.4 times 10 to the 24th grams. I mean, it weighs tons. So, all right, so what about this thing called molar mass? A molar mass is the weight of 1 mole of a given substance. So if I have 6.02 times 10 to the 23rd atoms of carbon, we just look on the periodic table and it weighs 12.01 grams. Right there. We don't even have to memorize it. So 12.01 grams, that's called the molar mass of carbon. Again, same thing with uranium. If you have a mole of uranium, So you have 6.02 times 10 to the 23rd atoms of uranium. It's going to weigh 238 grams, just looking at the periodic table. So that's the molar mass of uranium. So again, you're looking at your periodic table, probably going to have to print one off. And we're just going to look at that larger number. So, well, we have the same number of carbon atoms and we have the same number of uranium atoms. Why do they weigh so much less? Well, just by looking at the periodic table, we can see that uranium is much further down because it's a much bigger atom. Just think about everything that the periodic table tells us. So it tells us there's 92 protons, 92 electrons, and 146 neutrons. This is much different from carbon. It's a much lighter substance. It's only 6 protons, 6 electrons, 6 neutrons. So it's much different. One's a heavier atom. So we just look at the larger number in the periodic table and we're just going to add grams. So hydrogen. The molar mass of hydrogen is 1.01 grams. The molar mass of helium is 4.00 grams. So this is how much a mole of atoms weighs. Aluminum, same thing. If you have a mole of aluminum, it's going to weigh 26.98 grams. So it's very simple to just look at our periodic table. So we can use this number multiple ways, which we've seen this number and we said, all right, there can actually be a couple ways to look at that larger number in the periodic table box. The average weight of one carbon atom, and because it's so light, we have to give it its own unit. It's called the atomic mass unit. It's 12.01 U. So that's just one atom. We can also say, well, but if we have a mole of carbon, 6.02 times 10 to the 23rd atoms, that weighs 12.01 grams. So don't confuse them. You have to think about it's the same number, but it depends on what you're looking for. Are you looking for the weight of one atom, or are you looking at the weight of a mole of atoms? All right, so if we are looking at a periodic table and we say, well, what's the molar mass of zinc? And we're going to look at the larger number, and it's 65.39 grams. Because they're asking us for the molar mass, we're going to use grams. What about the molar mass of oxygen? Again, 16.00 grams. But what if it says, what is the average atomic mass of oxygen? Well, we're going to look at that larger number, but it's just 16.00 U. What is the weight of a mole of atoms of magnesium? Again, it's asking about a mole, 6.02 times 10 to the 23rd. We're going to use grams. It's talking about the molar mass of magnesium, 24.30 grams. All right, what if it wants just the weight of just one atom of magnesium? Same number, but you have to change the units. 24.30 U. What is the weight of a mole of atoms of gold? Again, you're going to look at the periodic table, and you're going to see the larger number is 196.97 grams, because it's asking for moles. It has a big number there. What if I have 1 mole of silver? Again, you're going to look at the periodic table at that larger number, 107.87 grams. How many atoms are in a mole? Well, a mole is 6.02 times 10 to the 23rd. So make sure you're paying attention to what the question is asking. Don't confuse the number of atoms in a mole with the weight of a mole. Don't confuse molar mass with average atomic mass. Same number, different units. Don't forget your units. And remember, you can always use your periodic table. What if I have a compound though? So remember, when we're talking about a mole, you can have a mole of anything. You can have a mole of atoms, a mole of pennies, a mole of molecules. It's always going to be 6.02 times 10 to the 23rd. So how many atoms are in 1 mole of copper? 1 mole is always 6.02 times 10 to the 23rd. How many pennies are in a mole? Again, a mole is just 6.02 times 10 to the 23rd. How many molecules are in a mole? It doesn't matter what you're talking about. If it says how many are in a mole is 6.02 times 10 to the 23rd. So we can use a mole with elements, with molecules, with formula units, anything. If it says how much is a mole, we know that that is 6.02 times 10 to the 23rd. So, but if we have a compound, it's not like I can find H2O in its own little box on the periodic table. So we're going to look at a compound and we're going to have to calculate the molar mass. So say I have a mole of carbon dioxide molecules. If we just look at the formula for carbon dioxide, we can see that there's 1 carbon and there are 2 oxygens. And that basically kind of tells us how many moles there are. So 1 mole of carbon, the larger number in the periodic table box is 12. And then it says we have 2 moles of oxygen. Each oxygen is 16 grams per mole. So we have to double it because there's 2 of them. And then we just add those numbers up. So we can get the molar mass of carbon dioxide is 44.01 grams per mole. Okay, it's just all about math, which I know you guys love. All right, what if they say we have 1 mole of magnesium chloride? And they're calling it formula units. So just by looking at this chemical formula, we can see there's 1 magnesium and there are 2 chlorines. So if we have 1 mole of magnesium, if we look at the periodic table, the larger number in the magnesium box is 24.30. And we have 2 moles of chlorine. Each chlorine is 35.45 grams per mole. We're going to add those guys up, and that will give me the molar mass. All right. One more example, and then I promise we're done. Here we have subscripts, or we have lots of subscripts, and then we have S2O3 is in parentheses with the little 3 on the outside. So how do we deal with these parentheses? All right, it's pretty easy to look here and say, all right, aluminum, we have 2 of them. Okay, it has the little subscript there telling us there's 2 of them. But when we get to S, you have to look at it and say, all right, there are 3 S2O3s. So in order to figure out how many S's there are, we have to take the subscript. Sorry, that should have been moved over a little bit. So we have to take the 2 and we have to times it by the subscript on the outside. So we're going to go 2 times 3 equals 6. Same thing with oxygen. We're going to take oxygen subscript and we're going to times it by the subscript on the outside. So we're going to go 3 times 3 is 9. Okay, so knowing that, we know how many moles of each there are. So we have 2 moles of aluminum. Look on the periodic table, and you're going to see that it is 26.98 times it. We have 6 moles of sulfur. Sulfur on the periodic table is 32.06 grams per mole. Times that by 6. And then we have 9 moles of oxygen, but a single mole is 16. So 16 times 9 is 144. We're going to add those together, and that will give us the entire molar mass of Al2S2O33 for a total of 390.32 grams per mole. So go ahead, look back through this PowerPoint slide. I hope it helped that I'm recording it. Let me know otherwise, and we'll keep going on down the road. I will have a worksheet for you so you can practice, because we know how much we love those worksheets. Hope you guys are doing well, and I'll talk to you soon. Bye.